Hi everyone. Now we are going to discuss about the optical isomerism, some important properties of optical isomerism. Before going into the topic, we have to know what do you mean by the term isomerism. So the isomer, the compounds which are having the same molecular formula but differ in the physical and the chemical properties are called as isomers. So this phenomenon is known as isomerism. Let us see one type of isomerism, that is stereoisomerism. So what is this stereoisomerism? The compounds which are having the same molecular formula but differ in the arrangement of atoms or groups in space is known as stereoisomerism. So this phenomenon is known as stereoisomerism. One of the important type is optical isomerism. Another one type is geometrical isomerism. So what is this optical isomerism? The isomers which are having the same molecular formula but differ in the rotation of plane-polarized light. Normally, optical isomers, they are having the property of rotating the plane-polarized light. So here, this optical isomers, they will rotate the plane-polarized light. If the rotation of the plane-polarized light into the clockwise direction, if it is a clockwise direction, then it is called as dextro-rotatory. If it will be denoted, the dextro-rotatory will be denoted by the letter D or the symbol plus. If it is an anti-clockwise direction, then it is called as levo-rotatory. It will be denoted by the letter L or minus symbol. So the main criteria. So what is the main criteria for a compound is said to be optically active? It should have at least one asymmetric carbon atom. What is this asymmetric carbon atom? Here I have drawn the example, that is lactic acid. Here four different groups or atoms are attached. Here we will find this one. This is the example L lactic acid. Here hydrogen is present, methyl group is present, hydroxy group is present, and the carboxylic acid group is present. So four different groups. We can find that different groups are present attached to that same carbon atom. So the main criteria for a compound is said to be optically active. It should contain at least one asymmetric carbon atom. This is the example. CH2CHOH, COOH, that is L lactic acid. If it is a clockwise direction, then it is called as D lactic acid. This is the two isomers, L lactic acid as well as D lactic acid. So this is a compound which is having only one asymmetric carbon atom. Similarly, this is the compound which is having the four asymmetric carbon atom, that is D-glucose. Here we will find the carbon atoms, four different groups or atoms attached in that one. So four asymmetric carbon atoms are attached. This example is D-glucose. Then one important term we have to know, what is enantiomer and what is diastereoisomer. So the isomers whose mirror images are not superimposable on each other and rotate the plane polarized light into the opposite direction. So we will find that one, that two hands are there, they will not be superimposable on each other. That one, like this, that one is known as enantiomers. They are mirror images and they are not superimposable on each other and rotate the plane polarized light into the opposite direction. On the other hand, we have to know what is the term diastereoisomers. Here, the isomers which are not mirror images and rotate the plane polarized light in the opposite direction. That one is known as diastereoisomers. Next term, chiral molecules. Chiral molecules means compound in which four different groups or atoms attached to the same carbon atom. They are called as chiral molecules. Here the same example, lactic acid we have drawn. So four different groups or atoms attached to that same carbon atom. That one is known as chiral molecule. what do you mean by the term mesocompounds? Mesocompound means they are also having the asymmetric carbon atom, but it will not rotate the plane polarized line. Why? They are not rotate the plane polarized line. So mesocompounds are compounds in which same environment is present in the opposite direction. So if you draw an imaginary line that will divide the molecule into two equal halves. So same environment will be, if you see here, this one is the example for meso 2,3 dihydroxybutane. So here the same environment is present in the opposite direction, hence it is optically inactive. So meso compound, they are having the same environment in the opposite direction. If you divide the molecule into two equal halves, the same environment will be present in that. So this is another one example, that is meso tartaric acid. So here also the same environment is present, so it is optically inactive.